This is day one definition of derivative. Now, a linear function has the same slope at all of its points. And the slope of a linear function, usually we use the letter n, and it's your change in y's over the change in x, also called delta y over delta x. A parabola, for example, we have different slope at different points. Now, this is very important for you to know that here is no longer the same slope. It's different. So, tangent line. The slope of a tangent line is the same as the slope of the function at the point of tangency. For example, here's my parabola, and of course I have my x and y coordinate here. This is a parent function y equals x squared. At each point, let's say I pick this point. The tangent at this point would be a line that is tangent to the graph at that point. And if it is at this point, m may be equal to 2. Now at this point, which is the bottom, our graph different tangent. The tangent at this point would be a horizontal line, and if it's horizontal line, you know that the slope is equal to 0, and so on. I can find a different tangent, this time at a point somewhere here. It's making a tangent at a point here, and here the slope might be -5. Who knows? It will be a different slope. All right, to find the slope of a tangent line, you approximate the slope of the secant line by choosing points closer and closer to the point of tangency. So for now, I have these 2 points. The first thing I would do is, if this is x and I'm adding delta x to get to this level, it means that these points will have coordinates x plus delta x comma 0. Now it means that the point that is corresponding to this, and I also have a point here, the first one, this is f of x, and this is f of x plus delta x. Now we have our one line here. By the way, this point is the point x comma f of x, and this point right here is the point x plus delta x comma f of x plus delta x. Okay, let's look at the point of tangency. Let's pick 2 points. We have our 2 points, and after picking up the 2 points, we will look for the slope. So a point of tangency, let's assume is x. So I would say m is equal to change in y's over change in x. So delta y over delta x, that will be f of x plus delta x minus f of x over, again, this is my y2 minus y1 over x2, which is x plus delta x minus x. By the way, this is still the slope because I'm doing changing y's over changing x. If you rearrange this one, you will understand that to find tangency, to find the tangency, you will have to do the limit. So I will apply the limit here. It will be the limit as delta x approaches 0 of f of x plus delta x minus f of x over, if you simplify, you get delta x because the x's will cancel. Now, if you look at this closer, you will remember something that we worked over and over and over again. This is actually what you've been seeing. Limit at h approaches 0 of f of x plus h minus f of x over h. I don't know how many times you've seen this, but you've seen it so many times. All right, I hope you remember this. Let's keep on going. The slope of the tangent line is called the derivative. The derivative of f of x is denoted by the f primes of x. So if I have a function g of x and I'm looking for the derivative of the function g of x, all I need to know is g prime of x with this little apostrophe next to it. For each function, find f prime of x. The first function says the slope, the first thing we will find the derivative. Second, the slope of f of x at the specified x value. The equation of the line tangent to f of x at the specified x value. The first function is f of x equal x squared plus 1, and the point given is at x equal -1. What I will do is I will apply the function. I'm starting with a. I will do f of x plus h minus f of x over h. That's the first thing I will do. Of course, I'm looking for the limit. I forgot to write limit here. So I'm looking for the limit at h approaches 0. And I'm doing a. Alright, let's go ahead and look for that limit. So it means that it is the limit at h approaches 0. F of x plus h will be x plus h squared plus 1 minus x squared plus 1 over h. This should be very familiar to you. So if you expand it, you still have the limit at h approaches 0. Note that I keep writing the limit of this will be x squared plus 2xh plus 1 minus x squared minus 1 all over h. From here, I will go ahead and simplify. If you simplify, this x squared and this negative x squared will go away. The -1 and the +1 will go away, and you're left with 2xh over h. Oh, I'm missing an h squared. I am definitely missing an h squared because x squared plus 2xh, I'm missing a plus h squared here. So you're left with 2xh plus h squared. If you find that limit as h approaches 0, let's first simplify. So we have limit as h approaches 0. If I simplify one of these h's on h, the power will go away, this h goes away, and this h goes away, leaving you with just 2x plus h. And this limit as h approaches 0 is nothing other than 2x. So this is my final answer for A. Let's move on to B. B here, I will say, I will plug in -1. We have it at x equal -1. Plugging -1 into the limit, that will be 2 times -1, which is -2. And the last one, which is C, we know that the slope is equal to -2, and it goes through the point x equals -1. I will use the point slope formula, which is y minus y1 is equal to m x minus x1. Y minus y1 will give me y minus y1 here is 2. In case I plug in -2 in here, in case I plug in -2 here, I get 4. 4 plus 1, 5 is y minus 5 then is equal to m, which is -2, times x minus x1, which is x plus 2. So if I rearrange it, and this is a 1 because we're plugging x equals -1. So if I plug in -1 for x1, I get a +1 here. Now from here, all I have to do is rewrite it. So I can solve for y here and get just the equation, or I can even leave it as it is. But if I do solve for y, I get y equals -2x. That will be -2, but +5, which is +3. Once again, this is also acceptable. But let's go ahead and look at problem number 2. On problem number 2, what I would first do is, of course, the a part of it, I will find the limit of 3 times x plus h, the whole thing squared, minus 4 times x plus h, plus 1, but minus 3x squared minus 4x plus 1 all over h. So if you find this limit, as h goes to 0, it will be equal to the limit of, I'll go ahead and expand this one. The 3 will multiply, actually let me show my step here. X squared plus 2xh plus h squared minus 4x minus 4h plus 1 minus 3x squared minus, actually plus 4x minus 1 all over h. I will do one more line with details. H still is going to 0. Limit as h goes to 0 of 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 1 minus 3x squared plus 4x minus 1 all over h. Alright, let's go ahead and simplify. I will highlight the stuff that simplify 2 by 2, starting with the 3x squared and the negative 3h squared will be gone. I have the negative 4x and the 4x will be gone. I also have a negative 1 and a 1 that will leave. All I have left is in terms of h. So I will go ahead and simplify the h out of all of them, giving me this. The limit as h goes to 0 of, once I simplify an h out of this, I get 6x. I simplify an h out of this, I get 3h. And an h out of this, I get negative 4. Well, if h goes to 0, my final answer will be 6x minus 4. Let's deal with the b part of this problem. For b, all I'm looking for is to plug in to have at x equal 2. If I plug in 2 into 6 times 2 minus 4 into the limit that I just got, my answer will be 6 times 2 minus 4 will give me 8. The c part of it, well, we know the slope is equal to 8, and we're looking at x equals 2. What we're looking for is actually y equals what? So what I would do is I would do y. Let's first find the y value. The y value of this one, if I plug in 2 in here, 2 squared is, I'm taking this 2 and plugging in here for x's. 2 squared is 4. 4 times 3 is 12. Minus 8 plus 1, it will give me a total of 5, I believe. So I did 3 times 2 squared minus 4 times 2 plus 1, and I got this 5. From here, I would now say y minus 5 is equal to m, which is the slope, x minus, this one is 2. So this is all once again, I can stop here, but if you want to solve for y, you will say y is equal to 8x. This will be negative 16, but plus 5 minus 11. This is a better writing, but this is also acceptable.